Hello, everyone, and thank you for joining us today. So in this session, we have Ria Cheruvu, AI Ethics Lead Architect at Intel Corporation, presenting how to brainstorm novel ideas for data science R&D. Just a quick reminder to post your questions to the Q&A box and not the chat. And Ria, a reminder to you to start your timer. So off to you.
Perfect. Thank you so much, Simran. Hello, everybody. It is so awesome to be presenting to you today. So in this talk, what I'm going to do is go over some strategies for success that I've encountered during my career, both some gems coming from my personal journey as a data scientist, as well as some interesting insights that I've picked up from more experienced colleagues in the space. So really, the purpose of this is to spark a discussion. So throughout the talk, feel free to populate the chat with some ideas that you're having as you're listening to this, to exchange tips around how to brainstorm novel ideas for data science R&D. So let's get started. First, I want to introduce the data behind data science R&D. So let's take a look at some statistics. According to Stanford's AI Index 2021 report, in addition to an OECD white paper that's recently been published on the topic, it seems that there's about 34.5% increase in AI journal publications from 2019 to 2020. Similarly, going through a few other statistics, there's more than six-fold growth of AI-related publications on arXiv in the last 6 years. So this is just about publications and journals, but what about open source contributions? It seems that there's been a 3 times growth of AI open source contributions, which is 3 times greater than other open source contributions as well. Okay, so that's from the implementation point of view, and we've already covered publications and papers. But what about patents? Patents are an interesting way of trying to get your research out there and establish the novelty of your idea. We'll dive into the individual differences between these 3 different approaches in a moment. But essentially, it seems that more than 2.3% of IP5 patent families were comprised by AI-related inventions in 2017. So we can imagine that number dramatically changing over the next few years in order to account for the number of rapidly changing and newly developing AI innovations. So what's all this to say? Why are we looking at the data behind data science R&D? Well, it's quite obvious from these numbers that AI development and research is only going to grow. And with the proliferation of so many different types of ideas popping up, the question really is, how can we differentiate our own ideas and create novel and intuitive new solutions to help power the field forward? We also want to make sure that we're not reinventing the wheel here with existing solutions. So again, reiterating on that, we want the novelty, but we also want to be able to build on existing work without having to reinvent the wheel. So these 2 points are going to be recurring themes throughout this talk, where I'm going to be introducing some interesting ways or frameworks of thinking about data science research and development and how to build on top of existing work. So before we dive into concrete strategies, let's first take a step back and do a history deep dive. So what I want to present to you today is the evolution of computer vision and causal inference techniques and methodologies. This is going to be a very high-level evolution type of picture. So I want to direct your attention to the left of the slide first, where we kind of have a roadmap from the 1900s to 2000 in terms of the types of computer vision technologies that have been created over time. So what can we observe from this? We're starting with digital image processing and slowly starting to progress to some of these more machine learning oriented methods like Markov random fields or facial recognition and components such as these. So what we're seeing in this evolution is that one idea isn't necessarily better than the other. With respect to the resources and also the thought processes surrounding these ideas, at that time, those ideas could be considered the best. Of course, there are developments that are happening on top of that, but with respect to the past, we can see that there's been a very solid foundation already laid out that develops the motivation for each of these technologies sequentially. So here's an example. For example, let's take physics-based vision versus digital image processing. The use cases that we're seeing are starting to evolve as time goes across. And this is obviously, quite an important point, but something that can be revealed quite easily. What I'm trying to pay attention to and also bring your attention to is the identity of these different ideas as they evolve over time and how they're not really as complicated when they evolve. They're essentially just trying to be driven by the use case, but not necessarily trying to reinvent the wheel. So that's a lot of description there. Let's kind of clarify that further. The next example that I want to provide is with causal inference, which is the image at the right. So with this, the reason why I'm kind of trying to say that these ideas evolve sequentially over time, but they're not overriding each other, can be illustrated with this causal inference idea. The interesting thing here is that we're not considering a roadmap, but rather we're considering a ladder. So this was taken from Judea Pearl's The Book of Why, where, again, we're trying to develop the motivation for these ideas, but we're not saying that one in the past is worse than the other. So here in this ladder type of example, in the causal inference space, we're considering association, intervention, and counterfactuals as 3 levels of thinking. And for each particular level, there's a question that we would ask with regards to the data science task. Now, I won't dive into the details of the questions here, but again, essentially what I'm trying to illustrate is that there is a progression over time where we're starting to see more innovative technologies happening at the present and going forward, but that doesn't mean that they have to be more complicated or overriding some of the existing research. Okay, now putting that aside, what are strategies for success that we can implement now, as was the promise of this talk? So some of these you may already be familiar with, some of these you may be experimenting with, and some of these may not have even worked for you in the past. And of course, it's really all about personalization, where you take these strategies and you try to customize them for your data science journey and understand where they apply and where they don't. And I'll provide an example as a personal anecdote of how this has been easily integrated into some of the components of my data science journey, as well as some things that I may disagree with as well, and you may agree. So one of the first strategies that I want to discuss is brainstorming, then validation. And already this may start to challenge some of the best practices that have been put out there. Why? So essentially what we're trying to say here is to develop your ideas before turning to the literature. And of course, using keywords to help your search. So what does this mean? And we'll dive into this in a moment as well. What I'm trying to say here is usually we always start a lot of our research and development with a literature review. We go out, we survey the field, we try to see what's already been done out there. But with this brainstorm then validate idea, what I'm trying to convince you to do is to first take your idea and develop it further with the knowledge that you already have. So don't turn to the literature right away, but first try to iterate through your idea and think about, okay, so what was the cause or the motivation for this idea? How can I implement it? Where can I take it further? When you go through that thought process, you're essentially mirroring the progression that's happening in the literature. So when you go back to the survey, there are a couple of different things that could happen, but the ideal thing is that your thought processes are matching the processes of authors who have been publishing papers in this space. So let's move on to the second one for now. We'll revisit the first, as I mentioned. So filling in the gaps is, again, another obvious strategy for success when it comes to research and development. What we're trying to say here is to find the gaps in existing work and to fill them by motivating your use case accordingly. So here we want to use the limitations in future work that has been defined in, let's say, publications in order to inform our development. And the third strategy that I do want to cover here is being question and user driven. I've been mentioning being driven by a use case a lot. So really, throughout this talk, what you'll be seeing is if you do have a use case or a question that's already defined, a lot of these strategies may not make sense or may not even be required. Because once you have the question defined, you just start to find the methodologies and put them into place, kind of like solving a puzzle. But here, when you're being question or user driven and trying to find an idea that's novel and out of a pool where you don't necessarily have a clearly defined question, you need to motivate your research and development by developing your own questions and use cases. So a lot of the times these are research problems, like for example, okay, can I optimize my model to get X amount of performance in Y amount of time? But for different dimensions, we may also start to see different types of questions, again, evolving over time. For example, how can this project help users? Should I include a better user interface or faster methods or something similar? The last strategy for success that I want to talk about is challenging assumptions. And this is what I mentioned by personalization of these strategies. Your perspective is valuable. Thinking through and challenging best practices is imperative, and it's important throughout your ideation because, again, of that customizable aspect. Some of these may not work for you. Some of the best practices that have been developed may not even be factually true once you start to walk through them. And there are certain cases of this happening because researchers, let's say, might be stubborn to accepting new ideas, etc. Now, again, usually there's some motivation behind this. So it's important for you to first understand, okay, why am I questioning this best practice? And then to see if that aligns with the existing literature or not. And if it doesn't, then can you substantiate your points? Or may there actually be a fault in the field? And with AI and data science being a very rapidly evolving field, that may definitely be the case in certain situations. So moving forward, as I mentioned, I would dive into the brainstorm then validate idea. This is what the brainstorming spectrum looks like, in my opinion. So as I mentioned, when you make an interesting connection or pose an interesting question, my recommendation is to develop it first before turning to the literature. So I mentioned like the ideal scenario here would be that you do have a new idea, so you can kind of analyze the existing gaps and start working on it. But what if your idea already exists? It happens so many times in data science. So essentially, you kind of go back and reiterate through the cycle where you continue brainstorming along these lines, and you continue to ideate and work towards finding a new idea. Now, sometimes your ideas might have a false basis. This is when, because you didn't turn to the literature soon enough, you may not have a factual understanding of the field yet, especially if it's a field that you're relatively new to. So some of your assumptions may be incorrect. In this case, again, I'm trying to motivate you here to question some of the existing foundations. Why is it put into place in that particular way? And this is, again, related to that iterate and learning process. So for example, if you're using a certain data pre-processing tool and you are questioning some of its uses and its limitations, making sure to address that and to understand why are the limitations being put into place is an important picture for you to put together. So we'll continue to kind of cover some examples on that, but moving forward, I do want to address some 3 paths to R&D pretty quickly, where you can start to think about your projects or your data science research and development and structure them in certain frameworks. The first are papers, which are essentially focusing on the contribution of your methods. The second are patents, which are focusing on the novelty. And the third are projects themselves, which are focusing on the implementation and the code base. So papers are really results and reproducibility focused, as you may have already noticed based on some of the existing work that you may have done in research and development for data science. They start with the problem statement, move on to novelty and motivation. They do have the literature review as part of this, the experimental setup, and the results plus the discussion. And on the right, I do have an example of a paper, it's something just to keep in mind, but not necessarily something you do need to focus on. It's essentially a case study for showing how papers are mostly results focused. With patents, these are mostly application focused, where we're focusing on the detectability and advantages of the solution. For example, on the right, you see we have figures and we have a description of the system that's covering the overall holistic pipeline. It also covers the generic applicability of ideas to practical applications. And finally, we have projects. These are more application and implementation focused, where users are driving the use cases, and they're again focused on deployment and the advantages, but their twist towards novelty is being able to incorporate existing ideas as well as new ideas for the practical application, which is slightly different from the patent idea, where the emphasis is mostly on novelty. So a comparison of 3 paths very quickly in terms of papers, patents, and projects. You can see here that they all share some similarities. They're all motivated by a problem statement. They have some emphasis on novelty, in addition to an overall survey of the literature and the implementation aspect, whether that be the experimental setup, the code base, or also the advantages section of the patents, where you might create a prototype, for example, to demonstrate the novelty. But each of these do have their differences, and it's important to take note of that. And we're covering this very quickly during this presentation, but just to kind of start the discussion around these 3 different frameworks that you could take to start your perspective towards data science R&D. And finally, in the few minutes I have left, I'm going to be going over a very quick example where we're going to apply this to the attention for visual recognition space. So I'm going to skim through what's on the slide here, but I will provide the slides afterwards as well. So feel free, if you'd like, to kind of dive into it and kind of think about how this mirrors your existing research processes. So let's take an image, for example, and let's start with the question. There's so much information in images. How do I focus on certain things? So after doing, let's say, search engine search, you might obtain the keyword attention. Okay, so if we take that attention keyword, we might have a question after looking at, attention is all you need, for example, or similar papers, saying, okay, there's solutions for memory and attention for deep learning, but large tasks may require a huge memory. So how do you only remember relevant data when it comes to images? Then you might come across some keywords like attention and memory and deep learning, and come across a paper, for example, by DeepMind, where they present a solution for compressed memories for sequence data, which is applied to image data through reinforcement learning. So you might think, okay, are there other similar innovations for image data, and come across this keyword episodic memory. So then, given that episodic memory keyword, you're starting to dive into the literature very deeply. So here, let's take inflated episodic memory as an example, which is proposed in one of the papers. And essentially, there you're starting to extract some of the information regarding the problem statement and the methodology. I won't go into detail here, but the slide does a good job of summarizing the core parts of their invention that are relevant to the question that I initially posed. So here, long-tailed visual recognition is the task they handle, where they're looking at naturally distributed data with head and tail classes. So trying to analyze the data around images and their classification, which is a new problem statement. So once we take that, we can start to now look at different methodologies for solving this problem statement. For example, one paper proposes this idea of modulated attention or spatial attention applied on self-attention maps. So they're essentially doing some sort of double attention type of approach at a very high level. So given all this information and iterating back and forth again and again, we've already reached a very interesting research question. Can we apply attention again on images that already have been marked with attention in order to focus on relevant parts of an image? So now what I could do is take this idea and take the paper approach and perform a comprehensive study to answer the question, what are the types of problems that attention on attention could solve? As part of the paper approach, what I'm going to do differently from papers or projects is to confirm the novelty, perform this literature review in more detail that I just mentioned, and then design a reproducible experimental setup, and then afterwards describe my results in discussion. So here I'm building on top of existing efforts. I'm not really emphasizing on the novelty, unlike a patent. And in terms of the project perspective, I'm not really doing something that's user-driven or a package that people can install. This is more of an experimental setup and, okay, what results can I get out of this type of exploration, which is why a paper approach might better suit this perspective. And this is how we can see the three framework type of thinking or approach can help us understand how to approach this literature review in addition to brainstorming novel ideas for data science R&D. So I'll end there. That was a very quick deep dive into some of the ideas and strategies that I've encountered as well. And I'll take any questions.
Thank you, Ria. Okay, so we have one question, and it is, at which stage or how would you recommend to brainstorm the use cases and especially potential harms during data science R&D?
Right. So I think that this is a very important question to address at all stages of the pipeline. So, it's very easy for us to say, essentially, okay, you do have your question, you've defined it, everything is good to go. Analyze the harms of or the implications of my project at the beginning. I don't really have to do so throughout it. But even if you are question or user driven, there are multiple different components of the pipeline that will require mini brainstorming processes. For example, let's say a client approaches me, they need a data science method for a finance use case. I've got the question defined. I know the implications and harms of the potential technology. But even the algorithms or the data sets or the storage solutions, all of those decisions also have certain implications as well, which is why I would recommend trying to keep that in the back of your mind throughout the process and maybe do some self-assessments as well throughout the pipeline.
Great. Okay, we have one more question. So how long does this process take for you on average? Do you also do any sort of prototyping to help generate ideas as well?
Right. Okay. This is an awesome question. So yes, I think that really, again, the time depends on the way that you're approaching these. I think that this could differ based on the individual frameworks. On average, I think for me, it takes about 1 to 2 days to kind of go through the literature, do a good survey of it. And of course, coming up with a prototype is always, I think, a really good solution. For example, for patents, you might not necessarily be expected to create a prototype before just putting your ideas out there, because getting your novel idea out there is you may be in a bit of a rush if you're considering the patent approach, whereas compared to a paper, a publication route, or even a project. But nevertheless, 1 to 2 days for literature review is a good minimum to start with. And of course, developing prototypes is always great. And I think that adds on a significant amount of time to your implementation. So of course, it's your choice.
Thank you. Okay, one last question that we can answer live, and then any follow-up questions we can either answer in the chat or, people can send you an email, and I'll post your email in the chat right after.
Perfect.
So Sean asks, can you talk a bit about developing a patent strategy, or what are the right criteria for thinking about whether we should go down the paper versus patent versus project path?
Right. Okay. So with this question, there's a bit of a short answer and a long answer. I'll cover the short answer here and also maybe include some more details in the chat or the Q&A section as well. So essentially, really, it again depends on the purpose that you're trying. So with the patent approach, as I mentioned, the rush to get your novel idea out there into the world and make sure that you have the permission or the licensing to kind of go ahead and implement it without someone else coming and infringing on your idea is kind of the purpose or motivation behind patents. So you can consider it as kind of like a rough draft of your idea that you want to get out there almost immediately, you could say. With the paper approach, it is a little similar, but essentially you are trying to go through the development process and publish something that can be leveraged by the academic and industry communities as well. The project approach is more for your own personal experience or also focused on the user experience. If there aren't any existing tools that people are capable of using to solve a problem, then you're making it easier from the user's perspective to be able to leverage these. So that's a very short answer. Just to summarize it, patents are really about getting your idea out there, pretty quickly. Papers are about, doing more research and groundwork to bridge that to the community in a way that's accessible and reproducible. And projects are a way to make existing work and also maybe even some novel ideas that you incorporate in there more accessible to the community through a user interface or through a code base, with the focus being on your users. So I hope that answers the question.
Thank you. So thank you for the wonderful talk, Ria. This now concludes our session.